Good day everyone. Our topic is all about Gauss Seidel. So Gauss Seidel is an iterative method used to solve linear system of equation. But before conducting a Gauss Seidel method, we have a reminder. So first reminder is it should be diagonally dominant. When you say diagonally dominant, the equation or the absolute values that the diagonal should be greater than or equal to the sum of the absolute value of the rest. So let's have an example. So my example is 5x sub 1 minus x sub 2 plus 2x sub 3 is equals to 12. And 3x sub 1 plus 8x sub 2 minus 2x sub 3 is equals to negative 25. And the last is x sub 1 plus x sub 2 plus 4x sub 3 is equals to 6. So when you see diagonally dominant, when we add the two sum of the equation, let's say negative 1 plus 2 is equals to 1 and 5 is greater than 1. So we can say that this equation is right. Then when you say 3 plus negative 2 is equals to 1, then 8 is greater than 1. So it's checked. Then x sub 1 or 1 plus 1 is equals to 2, and the 4 here is greater than 2. So we can say that this equation is diagonally dominant. So we can perform a Gauss Seidel. So our first thing to do is make an equation so that we can need to make an equation for x sub 1 so we can find the value of x sub 1. So 12 plus x sub 2 minus 2x sub 3 over 5 is the equation for the x sub 1. Then for the x sub 2, negative 25 minus 3x sub 1 plus 2x sub 3 over 8. Then for x sub 3 is 6 minus x sub 1 minus x sub 2 over 4. So getting all the equation for x sub 1 to x sub 3, we will put the initial values in order to get the values. So our initial value is 1, 1, and 1. And we substitute it for as a value, initial value for x sub 1, x sub 2, and x sub 3. So our formula for x sub 1 is equals to 12. So substitute the value of x sub 2, which is 1, minus 2 times 1 over 5. So equals, let's calculate. So 12 plus 1 minus 2 times 1 is equals, divided by 5 is equals to 11 over 5 or 2.2. So our value for x sub 1 is 2.2, and we will substitute it as a new value of x sub 1. So negative 25 minus 3 times 2.2 plus 2 times 1 over 8. It is equals to, so it's equals to 3.7. The new value of x sub 2 is 3.7, and we will substitute it in the equation x sub 3. So x sub 3 is equals to 6 minus 2.2 minus negative 3.7 over 4. So when we calculate it, 6 minus 2.2 minus negative 3.7 divided with 4 is equals to 1.875. So the new value for x sub 2 and x sub 3, we will substitute is in a second iteration. So our goal here is to make at least 3 iterations. So next is For second iteration, so x sub 1 is equals to 12 plus negative 3.7, which is the value of our x sub 2, minus 2 times 1.875 is over 5. And when we calculated it, 12 plus negative 3.7 minus 2 times 1.875 is equals to, divided by 5, is equals to 0.91. So it's the new value for our x sub 1, and we will substitute it in the equation for x sub 2. So negative 25 minus 3 times 0.91 plus 2 times 1.875 over 8. So when we calculated it, so negative 25 times negative 3 times 0. Ganyan. So 0.91 plus 2 times 1.875 divided by 2 is equals to negative 2.997. Then let's substitute this as a new value for x sub 2. So for the value, so 6 minus 0.91 minus negative 2.997 over 4 is equals to 2.021. So for our last iteration, we will substitute the new value for x sub 1, x sub 2, and x sub 3. So x sub 1 is equals to 12 plus negative 2.997 minus 2 times 2.021 over 5 is equals to 0.992. Then x sub 2, we will substitute this as a new value of x sub 1. So negative 25 minus 3 times 0.992 plus 2 times 2.021 divided by 8. So the value is negative 2.991. So x sub 3 is, we will substitute the new value of x sub 1 and x sub 2. So 6 minus 0.992 minus negative 2.991 divided by 4 is equals to 1.999. So for us to check if it is near to the roots, we just need to put the new iteration minus old iteration. So again, in getting, if the percent error is low, so we will make it is near to the answer or to the root. So in getting that, for the formula is new iteration minus old iteration over new iteration. So that's it for the Gauss Seidel, and